Hello friends, welcome to the first class of our front-end system design. So in the first class, we are going to see about the browser and its some internal features. This is very important concepts because later on this concept will help you to understand why there are some performance bottleneck and how you can identify where you can fix this and what are the different ways you can fix those. So for those concepts, you need to know some of the basic concept of browser and how it works. So let's start. So till now, most of us have an understanding that a browser is a program that downloads HTML and displays it, right? Like the browser is downloading the HTML file and it will display the web page. But that's not a correct idea. A browser is more than that. A modern browser is not a single program actually. It's a distributed system running on our machine. For example, Chrome. So Chrome runs as a multiple OS processes, each with its own memory space that communicates via the IPC. IPC means the inter-process communication. So let's say, for example, see this is a browser architecture. The browser will have separate processes, right? And each processes communicate via this IPC, that is inter-process communication. This is a local distributed system. So let's understand this little bit more. Suppose this is the browser, okay? And in browser, we have different processes. And what are the most important processes that we need to focus? Those are browser process, render process, network process, GPU process, and utility process. The browser process is the main UI process. Okay, so what does this do? So in browser process, mostly this address bar, this back and forward button, okay, these bookmarks, all this comes under this browser process. And since this is the main process, this will also manage all the other processes. Okay, all the other processes are managed by the browser process. Next comes the renderer process. So what is this renderer process, guys? So renderer process where the web page will get displayed. For example, here the HTML parsing, CSS, and the JS execution, layout, and the painting, all those things are done in the renderer process. In the network process, what happens? Network process basically handles all the network requests. For example, we do fetch, right? We do XHR. All those things are handled by the network process. Then the GPU process. The GPU process basically handles the composting, rasterization, video decoding, and also the image or the animation that we do, right? Those are handled by the GPU process. And there comes the utility process. So what is this utility process? Here basically it deals with the audio storage, downloads, extension, all those things are handled by the utility process. Let me tell you another concept, guys. This renderer process is the most important one, okay? Because since here all the actual web page working happens here in the renderer process. And also one thing, each tab will have its own renderer process. For example, if we have two different tabs open, so it will have their own renderer process. So it will have one renderer process here. And also that second tab will have its own renderer process. So that two tabs are not associated with each other. Let's say this is tab 1 and this is tab 2. And why this is so, guys? Because you have seen, suppose if tab 1 gets crashed, but for that reason the tab 2 still works, right? Why? Because they both have their own renderer process. Even if one renderer process get hampered, the other renderer process still works. It's that same concept like a microservice architecture. If one of the service failed, but all the other services work, right? That is the same concept here. And now, if there are different processes, if we need to communicate between these different processes, how we can do that? We can do that. For example, a renderer process can communicate with a network process. It can also communicate with the GPU process and vice versa with the help of IPC. That is inter-process communication. Now, we are coming to the concept of browser engine. So what is a browser engine? So browser engine is nothing, guys. So browser engine, so let's say this is the engine. Okay, so what it will do, it will take the HTML, CSS and the JavaScript code. Okay, so it will take all the HTML, CSS and the JavaScript code, and then it will convert that into pixels, so that can be rendered in our web page. So this is the main concept of a browser engine. It will take an HTML, CSS and the JS file. It will go to the engine, and the engine will turn that into the pixel files that will be rendered in our web browser. So there are different engines, right? As for example, the famous one is the V8 engine from Chrome. So every browser will have its own engine. In the renderer process, so where this browser engine basically stays, right? So basically we have this renderer process, right? Let's say this is a renderer process. So inside the renderer process, the browser engine basically stays. Which will convert the HTML, CSS, JS file to the pixel files. Let me tell you another thing. Every process will have threads in it. Okay, so renderer is a process, right? Inside renderer, there will be different threads available. So there will be different threads available there. So what are these different threads? The first one is the main thread. Okay, so in the main thread, basically what happens, all the important operation, for example, parsing the HTML, building the DOM, parsing CSS, runs the JS, computes the layout, the paint, for example, where those geometry, for example, we have one div, right, and one paragraph tag. Those paragraph will be placed in which position, that div will be placed in which position, that is basically done in the layout and the paint phase. All these type of processes will be done in the main thread. Then we have compositor thread. Compositor thread. So what is this compositor thread? So basically it takes the layers, basically the painted bitmaps, which is done by the main thread. So it basically takes the painted bitmaps from the main thread and then composites them and show them in the UI. It also, the compositor also handles the scrolling and animation without touching the main thread. Okay, so the scrolling and the animation all are done in this compositor thread. Then comes the worker thread. So what is this worker thread? So in the worker thread, basically what happens, if the main thread is very much busy, okay, suppose you have some very complicated JavaScript or runtime that will take some more time, okay, and it might cause some issue or slowness in your website. So what you can do, you can assign the task to the worker thread. So worker thread is nothing. Here basically all the web workers, service workers run in this, and it basically takes some task from the main thread and performs that, so that main thread can have some more time or the more capability to do some important task. And then comes the raster thread. So raster thread basically convert the paint instruction into actual pixels, that is the bitmap, that is basically done by the GPU accelerated process. So the important threads here is the main thread, the compositor thread and the worker thread. So in the main thread, basically what happens, if I tell, so because this is the main one, so if this is the main thread, what happens inside the main thread, basically it will convert the HTML to DOM. It will execute the JS. Then basically it will do the calculation, like for example, if calculation, for example, your div has a height of 100 px and a width of 100 px. So how much space it can occupy, all those type of things will be done in the calculation phase. Okay, like height with the CSS property, like height, width, all those things execute in this main thread. So main thread will have this function. Not only this, they have some more functions that we are going to explore in our next videos. But these are the main concepts happen here. And in compositor thread, basically what happens? In the compositor thread, basically it handles the scrolling and the animation, right? And which CSS property basically works here? The transform and the opacity. We have some CSS property, transform and opacity, right? Which makes the animation smooth. Even if the JS is busy, those are executed in the compositor thread. And then the worker thread, as I have told, it have web worker and the service worker. So in the main thread, so what is the most important task done by the main thread? The most important task done by the main thread is the critical rendering pipeline execution. That is critical rendering pipeline. So what is this critical rendering pipeline, or also known as CRP? So this is a very crucial concept that we are going to explore in depth in the next or some upcoming videos. But to give you a bit overview of this, so in this phase, basically what happens, all the HTML to the DOM conversion, the CSS are converted to CSS-OM, that is CSS object model. Then this DOM and CSS-OM will generate a render tree. So this render tree is nothing but basically the DOM structure with the CSS-OM structure, which is displayed into our browser. Along with that, all the layout, repainting, composition, all those activity also take place in this critical rendering pipeline. We'll explore these things in the upcoming videos, but for a overview, the main thread will execute this critical rendering pipeline. And another point to remember, main thread is basically a single thread. Okay, main thread is a single threaded, and it handles all the important tasks like the JS execution, DOM manipulation, style calculation, layout, event handling, all those things. That is why long JS tags blocks the rendering and input, right? So like sometimes our web page lags, right? Or it becomes unresponsive. Why? Because all our JavaScript execute in this single thread, in the main thread. And if it takes much more time, then any other task will not get performed, right? Suppose you are looping through a 1 million of data, and in that time you are trying to click something, it will not work, because since it's a single thread, that loop is taking the thread and that clicking is not working. For that reason, we will feel that there is a jank in our website. And what is the thing we need to do for that time? We need to move the heavy work to the web workers. We have this web worker thread, right? We need to move that to the web worker. Then comes the GPU process. So GPU process is basically shared across all the tabs. Okay. So even if there is multiple tabs, like suppose if I have multiple tabs, GPU process will be shared across all. So GPU process is basically responsible turning the paint into the bitmap instruction that is helped to display in our UI, and also composting layer, video decoding, all those things. Then in the network processes, basically it handles the DNS resolution, TLS handshake, HTTP caching, cookies are, proxy resolution, all those things are handled by the network processes. Just to tell you guys, renderer cannot make raw network calls. Okay, so it's not like that from the renderer you can directly call the network. They must ask any network process via the IPC. See, it should go via the IPC. Next concept is site isolation. So what is site isolation? So each renderer processes host content from only one site. Okay, even across the iframes. What does this mean? Like for example, let's say previously what happens, suppose we have this website, right? In this tab. So let's say this is a tab which has opened xyz.com. Now inside this xyz.com, we are also rendering one iframe. This is one iframe. Let's say of website abc.com. Now what happens, this tab xyz.com and this iframe abc.com previously had the same process, okay, had the same process and the same memory. So basically, let's say there is one memory here. So the xyz.com is also accessing that memory. This iframe is also accessing the memory. Why? Because both of them are having the same process. But for this reason, we have seen many security vulnerabilities happening. Then the site isolation concept came. So in the site isolation, what will happen? So we'll have this, the same thing, tab xyz and the iframe, but this iframe will be isolated. So iframe will also have its own renderer process. Okay, this tab, let's remove this. So now the tab have its own renderer process, and this iframe has its own renderer process. So for that reason, this iframe now cannot access this memory, the main tab memory, and hence the data leaking issue get minimized very low. Now let's see the concepts. So as I have shown, a browser process is basically a coordinator, okay. So it basically coordinates the network process, the different renderer process, and the GPU process. See, each site or the tab will have its own renderer process. And all of these are communicated with the help of inter-process communication, that is the IPC. Then the failure isolation. So what is this? Previously, as I told, the browser have some legacy monolith architecture. So every tab is basically have its own renderer, single renderer process. So if a tab got crashed, every other tab is also getting crashed. That means the browser itself getting crashed. But now with the modern sandboxing, what happens? We have different processes, right? And every tab will have its own renderer process. So even if site A got crashed, site B and site C will work as it is. So the crash or the failure is isolated now. Only one tab dies. Next comes what happens when we run any website. Okay, so basically if we try to open any website, so what happens? It comes under this renderer process. So in renderer process acts like a box, okay, as a security box, so that it does not access your OS files, folders, anything. Since the browser is running with the help of OS, previously renderer process shares the same memory location of the OS, for which reason the attacker or the hacker can access your OS properties like the memory location or some hard drives, okay. So now what happens? Now it's now having a sandbox like feature which have its own renderer process, memory, everything. So here everything happens, like for example, whenever we type http example.com, so first it will go to the HTML and CSS parser, then it will create a DOM tree, then with the help of JavaScript engine, the DOM tree, it will render and composite the infrastructure, and then it will give us the pixel that help us to view in the web browser. We also have the web API interfaces like the fetch API call and the set timeout, all those things, okay. Now another concept comes, what is this JavaScript engine? So every renderer process contains a JavaScript engine, okay. So what does this JavaScript engine will do? It will take the HTML, CSS and the JavaScript file and it will convert them into the pixel file so that it can be displayed in the browser. So this is example of a Chrome architecture. So this is the Chromium architecture where basically we have the networking, UI, security, all those things, okay. That is basically the browser process. Then we have this renderer process where basically the DOM, CSS, all the APIs are there. Then under this renderer process we have this JavaScript engine. Since it's a Chrome, we have this V8 JavaScript engine which will take this DOM, CSS and convert that to the pixel. So for different browser we have different engine. So if it's Firefox, then the engine is SpiderMonkey. If it's Safari, the engine is JavaScript code. What I told, if there is two different processes, the processes communicate with each other with the IPC, with the help of IPC, and each process will have its own memory space. Okay, they don't share a common memory space, they have their own memory space. But a single process, let's say an renderer process, will have a thread. Okay, say there is a main thread, so the main, after some work, the main thread can pass the work to the compositor thread or the raster thread or the worker thread. Okay, now the main thread bottleneck, what I told, like for example, if you are doing, let's say the main thread will handles all those things, right? Heavy DOM manipulation, complex style calculation, layout mathematics, all the JavaScript execution. Suppose in a loop, in a very large loop, you are doing all those things, then the main thread get blocks, right? The main thread is doing all those type of tasks. In this time, if you try to suppose click something, if you type something, they get blocked, because single thread, since the main thread is a single threaded, and that single thread is now performing the loop operation, right? All the operation that is inside this loop. So at that time, if you try to click, scroll, type anything, those get blocked, and for that reason we get unresponsiveness or the website feel lagness. So the browser as an ultimate security shield, friend, as I told, the renderer is now act like a sandbox, so it cannot access some other tab or your OS level file or folders. So now safely bridging the isolation gap, that means, see, the renderer process will call the fetch one, so basically it will now go to the network process, right? Because fetch means we need to call some network, and that network is handled by the network process. So the IPC, the inter-process communication, will pass the payload to the network process, and then the network process will validate it, the course validation, all those type of things, and then it will send the HTTP request. Now the principal engineer's diagnostic tree, let's say the app is slow. So first step, you need to see in which domain the app is slow. So for that, what you need to see if there is any network issue, or the issue is in the CPU or JavaScript, is it in the memory, or is it in the rendering stage. For example, let's say if it's in the memory, then what you can see, you can go into the subsystem. So what are the subsystem? It can be in the main thread, it can be in the GPU process, it can be in the storage API, or it can be in the browser or the inter-process communication layer, right? So if it's an inter-process communication layer, again you need to see if this is IO bound, for example waiting to fetch some data like that, or this is CPU bound, like you are doing a heavy calculation, or this is a memory bound. So now let's see a full picture of the browser and its internal processes. So let's say this is the browser. Here we have a network process, the GPU process, and the utility process, and these processes are shared process. Okay, these processes will be shared across every tab. Now each tab will have its own renderer process, and each renderer process will have its own main thread, compositor thread, worker thread, and also the render process will have its own JS engine. So basically it will take all the HTML, CSS, JavaScript, and it will convert them into the pixels. And if any process wants to communicate with each other, so basically they will communicate with the help of IPC. And as I told Fred, each tab will have its own render process isolated from each another. So if this tab crashes, there will be no effect in the tab 2. This is the overall architecture of the browser. And now let's see one of the important factor. So anatomy of a web request. So what happens, suppose if we type in URL and press enter, in browser what are the different processes that take place and how the flow works, right? So basically between the browser and the server, request and response, how the things works, let's see. So there are total 13 steps. So before that, what are the process involved in this? So here the browser process, which is basically the orchestrator. So it handles the user input, network routing, and the tab management. Then the network process, this is basically the external communicator. So it will take the request and the internet traffic to the server, and it will fetch the data from there. Then we have the render process, which acts like the factory. So it will turns the raw code into functional web pages, okay, and highly sandboxed from security reason. Here all the parsing, HTML to DOM, CSS to CSS/OM, JS execution, all the things will happen in the renderer process. And the GPU process, which is basically the hardware accelerator, it will translate the mathematical render layers into physical pixels mapped directly into the screen display. For example, where the image will be placed, where the video will be played, okay, all those things will happen in the GPU process. So in the first step, what will happen, that it will parse the input, okay, so user will give the URL, right, then it will parse the input. If this is a valid URL format, it will route to network thread to fetch the site. That means it will go to the network process. And if it's a plain text or a query format, it will route to default search engine, okay, it will go to Google or whatever the default search engine you have made. Then in second step, it will check the cache. So the network thread executes a strictly hierarchical of local checks to avoid unnecessary internet latency. What it means, friends, so it will check the local cache or the service worker if that URL has already been hitted previously or not. If it's hitted previously, it will take the response from there and it will not go to the internet. And if it's not there, it will directly go to the internet, okay, so it will go to the service worker, HTTP cache, everything. Then in the third step, it will look for the DNS. So what happens, friends, generally, so we have this website name, right, like abc.com, but these are the domain name, but internet will not understand this. So the domain name, so in the DNS, what will happen, it will convert the domain into its equivalent IP address. So whatever the IP address is associated with this website, let's say it is like 168.1.0.1 like this, and based on the IP address, it will search for that website. Then it will go to the TCP and the TLS negotiation. So basically it's establishing the reliable transport and secure encryption, okay, between the server and the client. Then the network process and the checkpoint will occur. So in the fifth step, so the browser will send the HTTP request and it will receive the response header, okay, and then it will check the browsing check. So here basically what will happen in step 6 and 7, basically it will check the content type. What is the content type? Is it HTML, PDF or image, or it will check for any malware or phishing data there or not. It will do the checking. Then in the 8th step, all the data stream that has been sent from the server will be gone to the renderer process, okay, so because here all the HTML, CSS, JavaScript will be executed and converted to pixels, right, and in the renderer process we have the JavaScript engine, it will display the web page. Then in the 9th step, it will do navigation. So what does this navigation will do? So the browser officially tells the renderer to take over. So now the work of the browser is done. Now renderer will do its work. So if renderer see, okay, the old content is not needed and it needs to reload it, so browser will just reload a new renderer process and then the renderer will show the site, okay. Then in the 10th step, what will happen? It will parse the HTML and process the CSS and JS. So see, so whatever the HTML data will come, it will go to the HTML parser and it will be converted into the document object model. Same for the CSS and JavaScript, it will go to the CSS and JSS parser and it will convert the CSS to CSS/OM, and the JS, it will execute the JS. Then the 12th step is basically the critical rendering part, which we will see in depth in the later videos. So what it will be done? So after the DOM tree is created and the CSS/OM is created, it will merge both the DOM and the CSS/OM to create a render tree, okay. So basically render tree is a combination of both HTML and CSS. Then it will go to the layout phase. So in the layout phase, from the render tree, it will see, okay, how much height is needed for this body, how much height is needed for this div or this button, okay. It will calculate everything in the layout phase and it will just make a viewport, okay. It will just create a layout or a blueprint of that website. Then in the paint phase, what will happen? It will convert the layout blueprint into actual pixels. Okay, that means all the CSS colors, text, images, and the visual style will be appeared on the screen. And then it comes to the composite phase. So combine the painted layers in the correct order to produce the final visual representation on the screen ready for the GPU. Okay, that means it will combine the layout and the paint phase, and then it will display in the browser. Then the rasterize and the composite layer. So here what will happen? Suppose if you have some GPU related some video or animation, it will be applied in this rasterize and the composite layer. Okay. So here all the things like the pixel conversion, everything, the background, text, image, all the things will be converted into pixels so that it will be displayed exactly how it is need to display. So this is the master blueprint. So here we will start with the browser process. So it will first parse the input, then check the cache, then it will go for DNS lookup and then establish the connection. Then it will come to the network process, because now when the connection is established, it will send the HTTP request, which is sent via the network process. Then it will check for the safe browsing and receive the response, right? So here it will check what is the content type and it will receive the response from the server. Then from that it will again go to the browser process. So what will happen? Now the browser in the site isolation, so browser will spin up a new renderer process and it will hand over all the response that has come from the network process. After that site isolation, it will go to the renderer process. In the renderer process, basically it will process the HTML, CSS, layout and the render tree. And then after the render tree is created, it will pass to the GPU process to rasterize. That means convert to pixel perfect and display it in the screen. So I hope friends you have understood what are the different process threads in the browser, and these concepts will help you to understand if any performance issue occurs, where you can check and what are the different concepts you need. Now you will have some in-depth knowledge and you can explain this to an interview also. So just a small request, if you like this series, just put some comment and like the video, and I will bring the next video within some days. So thank you friends, happy learning.